This video is about differentials. When we introduced derivatives, one of the notations we used was dy dx with respect to x. The derivative of y with respect to x equals f prime of x. So dy equals f prime of x dx. Dx is a change in x, and dy is a change in y. So when x changes by this amount, by how much is y going to change? By this amount. Okay, dy. And dy is called a differential. I'll give you an example, a real life example in a little bit. But first, how do you find differentials? This is one of the easiest concepts. If you know how to do derivatives, it is one of the easiest concepts. So I'll just pick an example at random. For example, suppose that you have a function y equals x cubed, and they want, what's the differential dy? Well, dy equals the derivative of this, which is 3x squared times dx. That's it. That means when x changes by dx, whatever this y is, it's going to change by 3x squared times dx. That's what a differential is. I'll give you another example involving the volume of a sphere. V equals 4/3 pi r cubed. The derivative differential dv is 4/3 pi, which is a constant, times 3r squared. The 3's cancel, so dv equals 4 pi r squared di. Okay, I'm going to write it with a different color. So dv dr equals 4 pi r squared dr. What does this mean? It means if the radius of a sphere changes by a small amount dr, the volume of the sphere will change by this amount. And let's do an example. Let's take the Earth as an example. Let us assume that the Earth is a perfect sphere, which it isn't. We'll assume that. Suppose when we calculated the radius of the Earth, which is, the radius of the Earth is 6.37 times 10 to the power 6 meters. Suppose that it's off by 1 meter. I know it's kind of difficult to tell, but let's just suppose it's off by 1 meter. So that means the radius dr is off by 1 meter. By how much is the volume? How far off is the volume? So dv, the volume would be off by 4 pi r squared times dr, which is 4 pi, and the radius is 6.37 times 10 to the 6 squared times dr. So the volume would be off by a huge amount. What I'm going to do is calculate this using the calculator. This is equal to 5.099, ignore significant figures, okay, times 10 to the power 14 meter cubes. So it's around 5.10 times 10 to the power 14 meter cube. That's dv. That's what a differential is. Differentials are used to figure out what happens to a quantity if you're measuring something and you're in error, like the radius in a sphere. If the radius is in error by 1 meter, the volume would be in error by approximately 5 times 10 to the power 14 meter cubes. That's a huge number. I'm going to do another example on differentials. (203) y equals, let's do this example, x cubed e to the x. So the differential dy would be the derivative of this, which is x cubed times e to the x. We're using the product rule. So first function times the derivative of e to the x, which is e to the x, plus the second function, which is e to the x, times the derivative of the first, which is 3x squared. All of this times dx. dy, there's not really much simplification, but I can take out x squared e to the x. That's it. That leaves me with x plus 3 dx. So this is the differential dy for this particular function.